Hello, this is Understanding Elon Musk, and as you can see, this is the back view of the dog run. I'm here in the outside room, the garden room or what sun room or whatever. Uh, you can see the cat is sleeping here. The dog, one of the dogs, also watching me. So yeah, we are all here. It is today Friday, and there is a typhoon coming here. That's why the reason why we went here this weekend. You can see that it's raining here. Sometimes it rains very hard. Sometimes it is a little bit. But tomorrow at around 6 o'clock in the morning, it will be the typhoon will be very close. As you can maybe see, no, yeah, here a little bit over here here, there, somewhere. You can see that there's a greenhouse, and that's one of the reasons always I have to be worried about typhoons hitting my place because sometimes the greenhouse gets demolished by the strong wind and branches falling on the vinyl. Uh, I didn't repair it the last time, so it is a little bit in a bad state, but I removed all the important stuff, so it is still okay. I'm waiting after the typhoon seasons to when it is summer to put a new vinyl cover on it, and then I will find a better way to make it resistant against these storms. Also, I found out that if you have vinyl and that you have it like for maybe 3 years, 3 years, around after 2 years, it gets harder. So there is a UV influence on this vinyl, and I think you have to every 2 years you have to remove it and redo it. But I also was thinking, if here in Japan you use vinyl, the temperature gets too high, it becomes a sauna. So I'm thinking about the to make it as a layered construction. So I will make you have this insect gaze or this insect cotton, so that blocks like mesh, a very fine mesh to block insects. So I'm thinking to build something on the side that it is uh, insect blocking a little bit. Now I think on the top, I think on the top you want to make this cloth stuff so that also the heat goes up. So on the side it will be more, I call it, I use plastic. So the plastic I will cut in two, and then I still need something when it is raining at the top. So I'm thinking about that, maybe some other stuff that I can pull something on over it when it is really storming, that it is enclosed. Um, Normally you have on the sides you can open a vinyl house, but the problem is if you open it on the sides, the heat in the summer goes to the top, so it's still an oven there. So I'm thinking about. I also thought about the construction that you can make a hole or holes in the side on the top of the roof so the heat can go out. Because if you can get out the heat out of the vinyl house and you just have protection against the rain or something, and it is construction that it is not blown away. Like normally you can say, okay, you make some like you can see the Asamaya here. He has a roof with an opening there. So on top of a roof there's another roof. You cannot do it vinyl house because the wind is typhoon wise, it will blow up your whole vinyl house. And this Asamaya is also good, but it's also getting old and it's just getting rusty. So I want to do this in the summer or in the winter. I will remove some of the panels of the roof that are rotten, that are rusted, and then I will replace them with some self-made uh, pieces of metal so that it is good again for a few years. The Azamaya, this the tea house, is made from a kind of metal sheets. So I have to take to have to replace them after now almost what is it 7 8 years. The legs, you can see the legs that are there here. You can see legs. I put some concrete because the dogs were peeing against it, and yeah, if you have pee with metal, it's gonna rust even harder. So that is something I place some concrete cover on that. So let's talk about where I'm sitting now, and you can maybe see the sound environment sound getting very hard because of the rain. So what I'm going to talk today is about the 3D modeling. This is also 3D, yeah, 3D world. So why is that important? So if you look at Elon Musk, and he's talking about real world AI. What is it? So also AI. My brother also studied three-dimensional virtual world. I was interested in it, but I gave up to it. I will explain later to it. Let me explain first. So the problem of one of the pieces of mathematics, if you study mathematics, is you have linears, you have lines, and you have all kinds of formulas. But one of the pieces inside of the field of mathematics is vectors, and that has to do with calculations for images, or for not for images, but yeah, you can see it as yeah, as images, as strength. You also use it for physics, like you have a direction, and you have a strength, and you have a three-dimensional direction. You can sometimes even have four-directional with a time or something. But yeah, these are vector calculations, and those vector calculations are also the if you want to know a little bit more about these are very simple. You add a factor, you can multiply a factor, and that's it. You can subtract a factor, and the constructions of it. So there's some calculations there, and this is exactly what it is used for rendering, for image generation. So this is also what a GPU can do, and this is also this GPU. So this is also has to do with AI. You have even vector databases, and you have even uh, this if you look at the formula or model, in reality it is like numbers here. It is a square of numbers, and that is also called a vector. So it has all to do with vectors, vector space, dimension space. If you they talk about parameters, like if you have 4 parameters for this stuff, it means 2 by 2. So you have a field 2 by 2. If you have 3 by 3 is 9. You have 4 by 4 is 14. So you make this is so you make a square of numbers, and that is your vector calculation. So and if you have a square, very big square with all kinds of numbers in it, yeah, this is also what this image is, because every pixel has an amount of a value. Normally 3 values. For three, you have 3 colors, RGB. So you can imagine for every point you have 3 numbers. So if you have a very big field with it's 1,000 by 700 is a screen. So you have 700 points by 1,000 points, but times 3, because you need for every point you need 3 numbers. So you can use a trick. So you have like for every position at 700 by 1,000, you have a specific number, and that number is a representation of the color. You can imagine that. So then you have in reality a screen, an image. And now you can use all those in your this is also a vector. So you can do all time. You can add an image to an image in that way. You just add those numbers. You take an average. You can make detection of in this vector of lines of lines that are like make a big jump. The one number is 1, and the second number is a very high number. So you can that is also called edge detection or something. So you can see all kinds of if you know a specific number that has a specific color, you can change that number into another color and into another number. So this has to do all with this stable. In our case, if you have a screen with 1,000 by 700, so 1,000 by 700 field of numbers, and you can manipulate this with vector with these mathematical combinations, and that is all. What is all that is everything what it has to do with AI and with numbers, because this is the model. We are talking about models of formulas. So you can connect a formula to all those points that are recalculated, and that is how these AIs works. That is what they are calculating. They are vector. They are always vectors. So okay, is enough. So, but you understand now that you can make an image with this, and get away from this thing. Uh, so that is how one of the pieces of an AI works. You can look at, for example, other how you call it, books about AI, recognizing of symbols or images or cats or creating of images, zoals Midnight German and all those. They also use those fields and they generate these values in this big table with numbers, and depending on your image, or 1,000 by 1,000, it generates a table, 1,000 by 1,000 numbers. That is what your image is. Because a computer only has one zeros or a value for a pixel, and that is the number that is in the table. So what is so important about 3D world and images, etc., and for real AI? So the problem is we humans see everything we see is two-dimensional. If you close one eye, we see a one-dimensional, two-dimensional picture. Yeah, we cannot see, but if you have one eye, you cannot see depth. Right? You can guess if it is moving, something is moving before something else. You can see, okay, this thing has to be behind it. But if you have a still, an image that is not moving, like an image or a picture, you cannot, you can guess the depth, because so far as something goes, the smaller it gets. But it can also be a trick. Some of the architectures from the old Greek buildings looks very nice, but they're using a trick to make it even more interesting. It's an optical illusion, because if you have only one eye, you can see the world. You cannot guess any depth in. If you are a cat with one eye, you cannot jump from a table to a chair. You cannot guess the. It is very hard to guess the distance. Only because if maybe you know or you guess, and you have to really guess because you don't know. So, and if you want to use this information with one eye of a 3D world, that is a picture of 3D world, you cannot. It is very hard to uh, to understand the world if you have only an image of a situation of a picture of like this garden. You will think, okay, I'm in front of this. Inside of this room, and outside there's the trees, etc. For us humans, if we see a picture, we already going to make a 3D world representation of this two-dimensional image for us. But for a computer, it is it doesn't understand this. So it is for it, it's just colors and it's just numbers, and it cannot understand that one image is in front of another image. So what they started to do in those days is stereo vision, because humans have two eyes and animals have two eyes. You hear the rain is getting louder. And they're a little bit a different view. If you use one eye, close one eye, you open one eye, and you do the other way around, you see that you see a little bit an angle difference. This is the difference between your eyes, and this difference you can with this difference you can guess, strangely enough, your brain depth. You can see depth because you have two eyes, and this is called, and your brain combine those two signals, and it gives you, if you move, you see that things are closer, things are getting bigger faster, and things in the background are getting less bigger if you move closer. If I move closer to my laptop, I see my laptop getting a percentage bigger, like 5% bigger, but the door is only getting 1% bigger. And because of that fact that things that are closer are getting quickly bigger than things that are farther away, I understand, my brain understands that the laptop is closer to me than the door behind it. So, and all other things, if things are moving, your brain is very influenced by your image. What you see is very influenced by your brain manipulates this. And this trick is used by magicians. The fastness of the hand, you think an object is here, and then you do something and you're still there, but it is in the other hand because you didn't see how movement, or you look at something, you can see even sometimes, if you have a normal vision, you you sometimes concentrate on a specific thing in your vision that you don't see something what's in your vision you don't see. You focus too much on something like on the television, and something falls aside of the television and you didn't even see it, because you were too focused on that screen. So that's also very interesting, because a computer will always see the whole picture. It will not focus on a specific area of the image. So these are also things that are very interesting. Yeah, you see often that somebody in the movies is there, and something is a sight is coming near to something scary is coming near, and they doesn't see it or something. So a computer will something mechanical will always see us, but we are sometimes so focused on something just in front of us that we don't see, we don't even hear things around us. We are just so focused. So this has to do something with our brains and the movement. So about this 3D world. Huh? So with what they tried, my brother also did research for image recognition and making from images 3D worlds for his research. He did some kind of research for robotics. So they wanted to build a human and with a robot a very long time ago, that's 20, 30 years ago, the university. And he was at the visual laboratory. So his task was to make a robot or a thing to see three-dimensional. So they could pick up a cup and put it down and they know where it is. So they, of course, directly knew that one image you cannot do it, so you need to have stereo vision. So then he started to make software that the stereo vision of two pictures, it can make a 3D picture of something of 3D with depth. Then they started with video, and because you have multiple pictures and a little bit of movement there, he could create a three-dimensional world in its view of this. Also, depending on how far the cameras are apart of each other, you could make a three-dimensional view of what is in front of him with this software that he made. Uh, Also later, you can see with I think Microsoft had this extension for the Xbox camera. You put on top of your television with also with stereo vision, and if you move your hands and you step further, it could interpretate this. Huh? There are some games, a few games. I think it is a pity that's only a few games that use this camera uh, to get the input of what people are doing in front of the television. I think, but also there were also projects that Microsoft built this in the cameras of laptops. They wanted to use this for other stuff, for like pointers or for how you call it. For inbuilt into a laptop, but also for one dimension with one camera. So the goal was to try to get this same effect that you have with two cameras into one camera. So that was also a big study. My brother, when he did all kinds of works in the Netherlands, he went to Australia and he worked for a company that was exactly doing that. They had an add-on on for Windows to make like if like this video, you see your hands that they can detect the hands, like objects in the pictures, like hands, and see what they were doing. And if you use your hands and make a circle, and it knows at the point of your finger where it is, it can draw a circle on the screen. So this company where we work for did like object recognition and human hand recognition, and you can draw with your finger with the camera just on your laptop with the help of camera. So they developed, and he had a good job where he was living in New Zealand, and then Microsoft integrated a similar software into Windows, and indirectly or directly, this whole company had no existence anymore because yeah, you have an add-on for Windows for a specific application, but if Windows makes this application themselves and integrate it in Windows, yeah, you're out of business. Nobody will buy this stuff. So uh, he lost his job that way, and now then he went to another job for making a spectrum analyzer, yeah, because you have a lot of sheep and cows in New Zealand, and the spectrum analyzer was used to measure milk and other things for the farming industry, and he found a good job there, and he built a spectral analyzer that you can plug on onto your USB. It's a very small one, and they can analyze the milk and all kinds of products, what kind of materials in it. That he built software for that. And he found again a nice job, and that job will also moved to Germany a little bit, but the main company will still be in New Zealand, and that's the job that he's doing now. I never did something with 3D. I had a competition with my brother sometimes that we were trying to make a 3D game. and I always manipulated what you were seeing. So with colors, I made a picture or something that was moving, but I didn't move at all. What I did was I used multiple pictures, like 60 pictures for 1 minute to rotate, and with colors, I used those images in memory and I swapped them out. And I did use colors for tricks. So I reassign the colors, and then you get this effect of a rolling ball. But in reality, I draw once the ball in different colors, and you only see them, you see only in black and white. And then what happens then is that if I start my software, it rotates all the lines from a specific color to another color to white. And the only color you see on the screen is white. So the blue ones, the red ones, the yellow ones, you don't see. So I have a line that is red, and I move red to white, and then I make blue to white, and the previous white I make red again. So what that happens is you have the illusion that something is moving very smooth, because the only thing what I'm doing is, if you remember these factors, I just change the numbers. The color number, red is for example 32, I change that into 100. That's right. And then if after 1 second, this 100 I reassign to 32, and another number like 15 I make 99. And if you do that ping 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 after every second you change another number to 99, that is right, you will have the illusion that you see something move, that a white line is moving. But in reality, you already drawn all those lines in the picture, so your picture is already there, already there. And I use a filter on top of this picture that it only shows the 99s, and the rest become 0. So the real picture has like all the kind of colors, but I make a kind of filter on top of it that you only see the 99, and that is what you're seeing on your screen. So in your screen you see a drawing of a ball, a mesh ball, black was 0, and then with white lines, it is 99, and you see that nicely rotating and all kinds of smoothly. And because it is what it in reality is doing, it is not recalculating all those lines in these positions. It is only switching colors. That was my trick. So I used that for my brother to get frustrated. Uh, how I get this smooth 3D, three-dimensional ball rolling. But of course, I told him. But he used really calculations and computer power. He could in the beginning not match my speed, and in reality you cannot match the speed because I don't do any calculations at all. A very simple calculation only. But he understand that my lesson to him was this, that your eyes only see what you see is exactly what you have to build. You don't have to calculate, you have to do difficult. So the initialization of the picture takes time, like a minute, to build up the whole images, and then it is like super smooth. And this was one of my ideas of tackling this project. But my brother made like software that is very optimized in machine code to recalculate those lines everywhere with formulas, and you saw talk 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 talk. He showed the ball rolling, but it was really calculated. So I always when I see a problem, I only look at the end result. What is the experience the customer sees, or what the user sees? And that is how you build your application. You don't think, okay, this is the problem, I want to make it real. What kind of formulas do I need? No, I always look from the other side. What is the end result? And what is the simplest way to get the end result to the customer without using calculations or difficult things? So, and that was the idea. I said, you see an image, and the next image is another image. So if I can make 50 images that looks, because it is repeating. So that was the whole trick. And yeah, uh, so so this learned that the bad thing about the whole exercise was that I was not interested in these factor calculations. My brother was very good at it when we were young, and he started this project, what I already told you, it is stereo vision for robots, and he made really software for three-dimensional, so he could use a robot arm to see if the object was in front of or behind of it. He could at the end create a robot that could pick up an object. Yeah, that was already, what's it, 20, 30, 40, 30 years ago, 20, yeah, 35 years ago, I was working here at the University of Utrecht on this project. Even Berkeley was in that time interested at this so he really made a simulator, a real world simulator, and that became later the simulator he used for all other kinds of work he did. So, so what does this mean? So, I also understand what simulator is, but I'm not interested in the formulas. And if you get really in this, you have, he explained me, if you have like you create a 3D world, yeah, and you would use a vision of that, you will see endless in this 3D world. So this is not what you want because you have to calculate everything. So a normal vision or the normal view has a limited reach because of the curving of the earth or like mist or something or cloudiness or something. And if you can imagine how cloudy it is, less you can see. So he limited his view first, and then he used mist. If it was mist, you could even see less, and only bright objects or something of shape still. So he used all kinds of very complex formulas. At the end, he had to even use like supercomputers to make those calculations easier, because he learned from me also. You can use very complex formulas, but if the end you want to have a formula that is only adding and subtracting, and then maybe multiplication, but very simple calculations. This was also because we used an ARM processor. That was the Archimedes computer from BBC. That computer was super fast with simple multiplications, simple instructions. So he reduced all the formulas in simple instructions and pushed that to those chips. Then he had the problem that he saw people using supercomputers, and then he saw also that he could do the computers with GPUs, with graphic cards, because they also use factors. So he changed his whole simulator software to run on a GPU, and he could create the 3D world running on these simple calculations. And this is before everybody, before graphic. This was used by other companies. Even gaming companies were interested in his simulation software because he got this. He got performance that was better than supercomputers. Also, the defense department in Europe, a brother works also worked for defense. They were interested in the simulator because they used what I said on Silicon. They used really big computers, very expensive computers for running simulations, and he could beat those computers like 10 times faster by simple four computers combined with graphics cards. And the other computers were like millions of dollars. This Silcony graphics cards, it's very expensive computers. They needed like supercomputers to make these simulations, and he could beat it with an almost with an later he could even beat them with a normal PC with a good graphics card. So you understand this is before like all the 3D games and rendering and all those all the other stuff was happened, and it was also proprietary software. He made this was his proprietary software, so this software never went to gaming or it is used by military, but it is not used by gaming industry. This may be a pity, but yeah, that's it. Because we also were thinking about making our own game. But because of this journey of my brother of the 3D world, I understand a little bit more about the problems you have with the 3D world and interpret it. So everything you see with your eyes is a reflection. Is like what the 3D world is. So if you have like what we have now with Midnight Journey and all those these image generators, what they in reality do is they create a two-dimensional image, a presentation of what you put in your prompt. So you have a prompt with objects. Those objects it will recognize, and it will paste them in a logical, try to find a logical way to put it in an image. And it learned those orders or how to place them in image because it is trained with other images. So if you describe something that it is very good trained on, for a wolf in the woods, it has a lot of examples of that. It can create a good picture of a wolf in the woods. But if you ask to have a wolf upside down in a very strange thing that is never trained for, it doesn't know how to place the wolf in what position. It doesn't know what to do with it. And then you will see a wolf placed somewhere in the picture. The position will be a little bit correct. The object was also correct, but how the wolf looks like is totally not correct. That's also probably why you see, if you see fingers or you see a hand, that is often you can see if an AI generated the pictures, also the face, because there's so many examples of hands and faces, it doesn't know exactly how to do it. So to resolve this issue, with hands and with faces and with other things that are a little bit morphed, a little bit strange, is if you make it an object. So there is now also software, 3D AI software that can make 3D objects. You can say, build me a house 3D, and it will give you the whole software or the parameters, the vectors, to create a three-dimensional house in a three-dimensional plane. It can also now create whole landscapes, trees, all three-dimensional. That's maybe a little bit of trick with it, but it can do this. So you can imagine that you have a landscape, three-dimensional landscape. You place a three-dimensional house there with a three-dimensional river. It knows that the river has to be in the plane, and which plane it has, like the surface plane. The house has also to be on the surface plane with trees. So you can make a whole three-dimensional not image, but environment. A three-dimensional environment with objects in it. That is probably what they are now doing, and I think that is very important to make this. So what is this advantage of? So if you can make a three-dimensional presentation, like from a house, etc., in the woods, etc., and if you have this three-dimensional picture, you can make a rendering of a two-dimensional image of it. And now you have the advantage that everything that now this two-dimensional picture shows is correct in the three-dimensional world. So the position where the objects are in the pictures, the composition will be always correct. Even the sunlight, the shadow, everything will be all right. Previous, it had to do with like machine learning. It had to learn like a billion millions of photos to understand this thing. But you can imagine, if it understands how to create a 3D world, how to place those objects that it is trained on in this, make a 3D representation in this 3D virtual world, and then you just make a rendering, a picture of it, the result of those pictures are much better than what you see now with Midnight Journey, etc., etc. Also, your eyes will be correct, your fingers will be correct, because it knows a hand has 5 fingers, it knows the position, the length, so everything will be atomically correct. Because that is how you make your model of a human, and the house will be also correct. Not some strange things with the roof fitting on the wall. It will be all nicely done, and it will be always be correct, and that will be like create images that are really very interesting. The texture, so that is what, like the face, the color, and the eyes, that you can maybe use for what they use now for Midnight Journey, that you train that with all kinds of examples you have from the internet. Because if you look at Midnight Journey, all those things, and you ask, give me a photo of a nice girl, I think that is the most trained data of the whole data set, faces for humans. It is very good at that, and it is very nice. But still, if you really create a lot of them, you will see that there is a percentage that is not nice, or there are faults in it. The eyes are crooked, the colors are wrong, eye colors are wrong, or something in the hair, or something is wrong. Still, because it is not, it's not created from a 3D model. It is just learned from all kinds. It is plagiarism, what Michio Kaku said. It just uses some other images and it combines it, and hopefully the combining is so convincing that it looks real. But if you really make it 3D, then you make then a rendering of this 3D virtual presentation to 2 dimensionals, then you will have much better images. So those companies like Midnight Journey and Dali Labs and all those things that are now making those images, people are very enthusiastic about it. It looks great, and I also like it very much because I also use it for the covers of my books. Especially those. What I like is those those art pictures, like a face in Dali or in Van Gogh, a landscape or a futuristic AI cover with all kinds of nice symmetrical shapes, and wires and colors and glowing effects. That's something I very like, and that has nothing to do with 3D modeling. But if I really want to use it for like I have a scene where a car is driving on the road with something, it is that is I have to generate sometimes 10 pictures to get the right picture, or maybe sometimes more. But if this would be really a 3D model, and then you make a rendering, a 2D rendering of this presentation, it will be the percentage chance that it is exactly what you want is much bigger. So I think so they can continue this research of what the Midjourney, etc., has, especially for texture, for the coloring and how to use specific colors and skins and all kinds of things. But the objects that are created with this Midjourney, they are not good. It is always will fail. You have to give so much examples. You need to reality create all possible combinations of pictures that are there. If the question comes there, it has to have a picture like that. So this is not doable, and data set will be too big. So I suggest that all the objects that there are, you make a software that can make three-dimensional objects. So human, female, male, a dog, a car, make them all three-dimensional stuff. So if you have a prompt for an image, it will create a three-dimensional picture of that prompt. Then it uses the coloring and all the things that they already now have, that you can learn with other images that exist, and use a texture over those objects. I think that way of training or making an image or a movie generator will be the solution for what we now have for real for movie generation for AI. Because if you ask sometimes to create two pictures with almost a similar print, you get totally different movements, totally different sizes. It's not the same. You can imagine that if you have like this three-dimensional world you created with your prompt, and you asked the next image to move the object a little bit, or you zoom out, or you see it from another position, from above, your objects will still be the same. And then, probably you can also manipulate that the faces stay the same. So then you can make like a movie set, and you can move around it from different angles. And I think that idea is the way we have to make that is the idea how we have to go. I think the way we are now going to make images is not the way to make movies. We need to make first a three-dimensional presentation of our prompt and use that as a kind of base to make images of. And also we must be able to move those objects in our virtual world. So we manipulate those objects in the and use reoccurring objects that we can you define an object, and the AI will know that this is how the Azamaya looks like. And every time if you make an Azamaya, it looks exactly the same coloring, the same, everything is the same. So you can then reuse it in pictures. So you then make a library of all kinds of objects, and then you will have you can create movies. Also you can use then a skin of a famous actor, and always move that as that skin on that 3D model of a person. So I think that the three-dimensional creating a 3D models in a three-dimensional virtual world is more important than making two-dimensional images. Two-dimensional images will always be a mirror image of reality. So that is also why that's also I think what Elon Musk saw. They first saw lost an image, and they wanted to see from this image the road situation, car situation, how to react to car situations. Then they found out they need at least two images to find depth. This problem with depth was solved by some LODA, With radar, that's easy. You make a three-dimensional picture of your environment, and then you use the image on top of it, and then you can see the situation. But then they found, I think then Elon Musk found out that if you have like two images after each other shortly, it is almost the same as stereo vision. So you can only use one camera can already create, and if it moves, you can create a three-dimensional world. This needs, of course, more computer power, and you need more images. It is more difficult to make, but this is possible. This is also what my brother saw is possible. And I think the other companies were too lazy for this, and they want just to get this radar image data. It was much easier. They had directly the three-dimensional stuff, but they needed an extra radar for this. But so this is maybe the simplest explanation why you don't need a radar. Camera can do it, but it needs to move a little bit, and you always move. And so the camera or two cameras or one camera can easily create a three-dimensional world around it. And if you have like enough 8 cameras around your car, it can, and you start your car in the beginning, it will not know, but after a while you are driving, like maybe a few minutes, it can create the whole everything it is around it can make it three-dimensional, the same as a radar. So there is no difference then between a radar and an image. The only thing is you need other software. The software challenge is there, but yeah, those people at Tesla are great programmers, and they know about three-dimensional worlds. So for them it is easy to create this. You only need more computer power to do this, instead of you directly getting the data from a radar. So they are already studying this this 3D world interpretation for their car, and the AI reacts on those objects in their three-dimensional world. So how to find how to do the edge detection of a road, how to find objects, how to find a car on the side of the road, people walking around, crossing the street. All those problems an AI needs to do. They already trained with this. They already know this the whole three-dimensional world, how it functions, and how the AI has to react on those objects that are moving in this three-dimensional world. That's how the AI is trained. That is driving. This is totally different from what OpenAI and BART is doing. They are just predicting the next word in a line of words. So this whole research that what Elon Musk did is what he said is thousands, so much. If you use a telescope, if you look at him and you look at the technology that OpenAI uses, the method, you need a telescope. So far back behind is it. So they are so far in front of like OpenAI and BART with the real world, the three-dimensional interpretation and understanding of the AI is so far ahead of just predicting the next word. So the only thing now, what people say, for AI to go make it for OpenAI or for BART to make a self-driving car to understand the three-dimensional world is not possible with predicting the next word or what they have now made. So they have to rebuild a new model, and and even the way they interpreted two-dimensional images is not good. But I said you need three-dimensional, and that is exactly what the car and what the robot, the Tesla bot and Elon Musk did. He stepped to a three-dimensional world, and he used LMM, dus the large language model, for predictions. So because those objects are predictions, so you make a story what you see, and you predict what is going to happen next in this story. And so you see an accumulations of 3D objects, and you predict with making a story what will happen next, because you cannot predict with the movement. The story is often very simple representation of what is in the picture, and you see that it is easier to predict what happens in a story than happens in the real world. It was strange, but for example, if you have a road, yeah, you know that it can be a T road or a Ford. There's a limited number of roads. But if you look at the image, there can be an unlimited possibility where to drive. But you know, with normal thinking and text-based and word-wise, that there are only a limited way. So that was one of the problems. That's why they use also these language models and what they use for driving. If you you describe the situation, the 3D situation, huh? You can easily predict what's going to happen. For example, you say a child is running on the from the road from the pedestrian road to the road with this speed what will happen next. So it's easier with a language model to understand it to cross the road. But for an image, for data-wise, image-wise, it is still very difficult to understand the intention of an object. The child, what's a child? I don't know. It is just an image of a child. But story-wise, you know, child has this behavior, so it will cross because it was running behind a ball. This logical, running behind one object, chasing a ball is easier to predict with a language model than with an image model. So that's why they combine this image model with this language model, so they know how the 3D objects in their images are behaving. Now also cat and a dog, you can interpret this. If you recognize a three-dimensional object as a dog, a three-dimensional object as a cat, you know, well, you don't know those objects will chase each other if you just look at images, but if you have a language model, you will know they don't hate each other and they will chase each other. So they will walk not side by side, they will rather will run away from each other. And that reaction that has an influence on the 3D world, and also you have to be careful with your car. If you see a cat and a dog side by side, you know, okay, you have to stop. Let's look what those two are doing. Just don't drive over a cat or a dog. So better to stop. But image-wise, you will not understand this. But text-wise, story-wise, you will understand this situation. So that's why now also Elon Musk is using these text models to predict what's happening in the 3D world he detected. So he already has this OpenAI and BART stuff. It's already in there. So, but only if he wants to make a chatbot, he just split off this piece, or maybe just doesn't keep it, but it will use tokens for it will be optimized for communications, for like talking, and not, but it will still have this three-dimensional stuff behind it. So it will be a much better understanding physics in the real world, this AI, than an AI from OpenAI. For OpenAI, this what Elon Musk created in the three-dimensional world for detecting is totally not possible. They will have to spend years and years, maybe 10 years or 5 or 6 years to catch up with this ID, what Elon Musk made already. So that means that even if you have BART or OpenAI and you put it in a robot, it will not be, it will not work as good as the FSD that Elon Musk already have. So for Elon Musk, it is very simple to upgrade his language model that he already has trained inside of his model, I think, but just add more to it, like maybe the whole what the training, the extra training set that OpenAI uses and BART uses. Just add that to the model, and you have to increase it because you also have a 3D model already in there. So you just add more information, and maybe I think this will lead to a very interesting model, maybe much better than OpenAI has. And I think if you can incorporate sound, then I think you're almost there for general AI. So then it has the thought, it has the vision, and it has the ears, and it has the audio of the real world. That is much closer than you just have a token and you predict the next word. Okay? You understand? You just OpenAI and BART just predict the next word. Elon Musk has a three-dimensional understanding of the world. It uses for the objects, it can recognize the objects, and it with the language model, those objects, it can create a story, and it will know how they will react in the 3D world because of story-wise of the information it has from this language model. You understand? This is much more advanced than anything that OpenAI and BART has made. So that's also why this is probably Elon Musk company is a real AI company, and the other companies are not AI. They are just predicting. It is like the game of words. It's really the game of words. What OpenAI and BART is. They are just playing with words and the order of words. Elon Musk is seeing the real world and predicting what's going to happen in the real world and can learn from the real world. And that is totally different than predicting a next word. It also has this function of predicting the next word for in a story. So what happens? So that's how it thinks, what the situation is, what it discovers in the real world, and how it probably will end up. It has probably some scenarios. It can go this way or go this way or this way, and then it chooses the best solution or the best, probably the biggest chance what will happen, and it will act on that, and then it can correct if it is something else is happening. It will rethink what is happening in the real world with this prediction. So that is what FSD is doing, and this is totally different from any other company what they are doing, and that is why I want to end. Elon Musk is with Tesla is a much more advanced, not 1 times fast better, but 10 times. But I think it is more in the 100 times better AI than OpenAI and BART. BART and OpenAI and even Midnight Journey and all those other DALI and all those other things that create images, and that it is based on this generous model with transformers and so what predicting the next word. Though it is not the real world. It is a fictitious world. And that's we for humans are not living in a fictitious world. In the fictitious world, everything is possible. So that's why it can hallucinate, or it can tell the non-true truth. If it is based on the real world, it has to be true in the real world, and it will always, then it will be not lying or saying strange things. So your base will be built on the real physics and the real truth that is out there, and then it creates a story or does something. With other things, it's just looking at the statistically way how words are ordered, and it creates a nicely ordered set of words as a response. So that is how I want to close. So people are right. If you look at the really company that is AI, software-wise, I think Tesla is the furthest in the world. Hardware-wise, I think Nvidia is also there, but they have to look out for the specially made chips for Apple and for Tesla, etc., etc. And even those, I think for Tesla with the Dojo chip, that is really optimized for this 3D, for their AI. And what is the best means at the end, this hardware will be also much better and much more applicable to their model than Nvidia. That's why they want to shift from Nvidia hardware to their own hardware, because the Nvidia hardware is not optimized for their model. So if they have optimized hardware, and this model will be the future model that everybody is going to use, Tesla will not have only the lead in the model, in the AI, but also in the hardware. So this looks very good. And I expect also that people will find this out later, maybe over 5 years or 6 years, that this is the case, and you will see that also in the stock market. And I think also that it will be a boost for Tesla if they understand it. And maybe for other people, programs that channels that are talking about this, they cannot really explain why Elon Musk AI is better than that of OpenAI or from BART. I explained it in this video, and I hope people will use this as an explanation why what is the difference between those AI models. See you.